Hello, and today we're going to be covering the 2020 SAC for circular functions. This is one of the SACs for Year 11 VCE for methods, circular functions. So let's get into it. The first question is asking you the exact value of sine, negative pi over 3. So we know that sine equals negative pi over 3, and so we're going to convert that, and that equals negative 60 degrees. And negative 60 degrees and sine, ignore the negative real quick and just focus on the 60. 60 degrees and sine is root 3 over 2. And now you add that negative over and becomes negative root 3 over 2, which is why the answer is C. For this question, it's asking you the exact value of 3 over 2. This is very easy if you remember the exact value tables. It's a table with all the exact values. I recommend you memorizing it, all of it, if you want to do well in it anyways. So the exact value of 3 over 2 converted to degrees is, again, 60 degrees if you're talking about sine. And so since it's 60 degrees, it's closest to this point, and so it's going to be 180 minus 60, which gives us 120. And in this case, it's going to be sine 120 degrees as the answer. So the answer is going to be A. Also, if the angle was around here, it would be 360 minus what the angle is. But since it's around here, it's going to be 180 minus the angle of 60. So this question here asking us for the solutions of root 3 tan x minus 1 equals 0 over the domain of 0 to 2 pi. So basically you want to arrange for x. So you get root 3 tan x equal 1 by moving the negative 1 to the other side. And because root 3 is in times relation to tan x, you move it to the other side by dividing it. And so you get tan x equals 1 over root 3, which is simply just, it's basically root 3 over 3 before rationalizing it. So that's it. And you get that angle of 30 degrees, tan 30 degrees, which is also pi on 6. So you have the angle pi on 6, positive pi on 6. Now, if you draw the unit circle, where on this unit circle, which quadrant is tan positive in? Obviously, it's the first and it's the third. So you're going to draw those two angles and mark them as pi on 6. Yep. So first angle, pi on 6. Pi on 6. Second angle, pi on 6. And this is when you start working your way towards your answers. So you start here from 0. You start here from 0 and you go all the way here to the positive side. You go anti-clockwise until you reach pi on 6. And when you reach pi on 6, basically what it's saying is x equals 0 plus pi on 6. And that's your first answer. This right here is going to be your first answer. And you keep going all the way over here until you reach pi. And you notice that if you keep going, you reach another pi on 6, which then means pi plus pi on 6 would be your second answer. If you keep going, you'll eventually reach 2 pi, since you've gone around 2 cycles. Going around here is pi, and then going around here back again is 2 pi. So it's going to be 2 pi plus pi on 6. However, you see, the domain is from 0 to 2 pi. And if you were to plus 2 pi plus pi on 6, that would be going over the domain of 2 pi. And so you don't want this answer. These are your only answers. These two answers are your only ones, since they are the ones inside the domain. Okay, so now you simply simplify it. X equals 0 plus pi on 6 is just pi on 6. Pi plus pi on 6 is 7 pi over 6. And here are your answers. These are your answers. And so your answer, try to find it, pi on 6, 7 pi over 6, yep, it's going to be D. So the next equation is asking you for the number of solutions possible of the equation 2 cos 3x equals 1 for the domain of 0 to 2 pi. Now for this type of equation, you only have to consider this, the coefficient of x. The coefficient of x in this case is 3, and that applies directly to the domain. And how does that apply? So when there's a number bigger than 1 to the coefficient of x, or smaller than 1, it has a times relation to the domain. And so in this case, it's going to be 3 times 0, which is simply just 0. And it's going to be 3 times 2 equals 6. So the new domain is going to be 0 to 6 included, always. So the number of possible solutions for this question is 6. Okay. In this equation, it's asking you the curve with equation y equals 2 minus 3 sine of 4x has, so amplitude and period. And to find the amplitude, first of all, you're going to have to look at this number in front of sine, always. So this number, don't worry about the negative sign. The amplitude is here. If the negative sign just means that it's been reflected. So the amplitude is 3. Amplitude. And the period. The period would be 2 pi divided by n, which is 2 pi divided by 4 in this case. And remember, the formula for finding the period for sine and cos is always 2 pi divided by n being the coefficient of x. So in this case is 4. But keep in mind that if you were to find the period of tan, it would be a little bit different. It's not the same formula. So 2 pi divided by the coefficient of x, which is n, which is 4 in this case, leaves us with pi over 2. And so with the amplitude of 3 and a period of pi over 2, we can search for the answers in one of these 5. And so A says amplitude of 3, correct. Period isn't 4, so incorrect. Amplitude negative 3, first of all, we don't have a negative, so that's wrong. It'll never say negative. Amplitude is just 3. Amplitude is 2, instantly incorrect. Amplitude is 3 and pi over 2, which makes D our answer. And as you can tell by E, it says the period is 4 pi, which we know not to be the case. Okay. A sine function f has an amplitude of 3 and a period of 1 over 10. So the period here is very important. So it's going to be 3 sine something, right? It's going to be 3 sine something. Something over whatever it is. And the way we're going to find that is we're going to take the period and substitute that into the equation that we use to find the period. So 1 over 10, which is the period, equals to the formula of finding the period. And so basic algebra here, what's it called? 1 over 10, so it's going to be, n over 10, since you're timesing the n to the other side, equals 2 pi. And you're going to times the 10 to the other side as well. So you get n by itself, which leaves us with n equals 20 pi. And so the equation you're going to be looking for here is 20 pi x. The coefficient of x. That's how you find the coefficient of x, which is also here. And so our answer is going to be it's going to be B. Because as you can see, the equation matches ours that we got. So here it's asking you to find the range, which is very straightforward, and it's always going to be the same. So the range of this equation here, it's always this number plus and minus this. So -7 minus 5 equals -12. -7 plus 5 equals -2. And so that gives us -12 and -2 included. So our answer is going to be C. Also, be careful not to switch these two around. So it's not 5 minus 7. It's always going to be this number. Okay? It's always going to be the number minus the coefficient of sine, I guess. The period for the graph of y equals tan. This equation. Okay, so it's asking you again to find the period. And we know the equation to find the period to be 2 pi over the coefficient of x, which is n, right? Now, don't be fooled. You see x by itself. However, the coefficient of x, which means a times relation, is still 2x. So the coefficient of x, which is n in this case, it's still 2. So 2 pi divided by 2. And the 2's cancel out. And you're left with pi. So the period for this case is pi. And, well, as you can see, it's inside the period, for the domain. A sequence of transformations which transform the graph of cos x to the graph of y equals -3 cos x. Okay, so if you've done translations and functions and all that, you'll be fine with this. This is basically nothing new. So we can see a dilation in the x-axis by factor 3. We can also see a reflection in the x-axis by factor, just a reflection. My bad. A reflection. So we can look for the answer. Dilation by factor 3 from the x-axis and a reflection in the x-axis, which is not here. A dilation by factor 3 from the x-axis and a reflection in the x-axis. So this is the one that we want, and so our answer is going to be D. The vertical distance, which means basically this way. This is vertical. The vertical distance in centimeters of a point from the ground is given by dt, basically this equation right here, right? Where t is the time in seconds. The vertical distance of the point of the ground after 6 seconds. Okay. So this question is asking you for essentially the amplitude. The amplitude. So after 6 seconds. the distance, my fault. The distance equals 13 plus 13. Basically input the entire equation, pi over 12. And you're going to substitute t in seconds with 6. And so you're going to solve that on a calculator. And basically, if you don't know how to use one, you basically just input, if you have a CAS calculator, you input solve. So x equals 13 plus 13 sine pi over 12 with 6, and you solve for x, right? And if you do that, you're going to get 26. And so our answer is going to be C. So this is very straightforward. It's asking you to express the angle of 160 degrees, 165 degrees in radians. And so the formula that we use would be timesing pi by 180. And so we get 165 pi over 180. And after simplification, it runs us to about 11 pi over 12. And this is the formula to convert degrees into radians. This question asks us the opposite. So we're converting this angle of radians into degrees. And so just like the formula up above, it's going to be flipped around. So 11 pi over 5 times 180 over pi. And the pi's cancel. And you do 11 times 180, which is 180 times 11 times 8, 1, 8, 1, 0, 8, 9, 1, which gives you this number. And remember, 5 is on the bottom, so it's 5 divided by 1980. And if you work that out, it goes to 300. So obviously, considering this first number here, 19, 5 goes into 19 3 times with a remainder of 4. 48. 5 goes into 48 a number of 9 times, leaving a remainder of 3. And 30. 5 goes into 36 times. So the answer equals 396 degrees. So this question is asking you, a lot of people get confused about this. I was confused as well when I first learnt it. They just don't know what this means, 0.72, what does it stand for, right? To put it simply, this question is asking you basically, if the value that's going to be added or subtracted is going to be 0.72. So basically just, you can have that as just 1, right? It doesn't really matter because it's always going to be making a difference. And this A right here, it's asking you what's going to be the value when pi minus this number, right? 0.72. And cos is, since the only angle that's going to be positive in the second quadrant is going to be sine, cos is going to be negative when it goes into the first quadrant, which is essentially what's happening here. It's pi minus this angle, which is going to make it negative 0.72. That's all you need to write. And so the second question is asking you, what's it going to be? It's going to be positive or negative when it's pi plus this angle, which is going into the third quadrant. Now, it's still going to be negative because only tan is positive here. Cos is positive in the fourth quadrant. So negative 0.72. Now it's asking you 2 pi minus. So now you're in the fourth quadrant, and that's when cos is positive. And so this time it's going to be 0.72 as it's positive. That's all you need to write. Okay. It's kind of similar to simultaneous equations. This question is asking us, it's asking us to find sine x and tan x, right? It's a very simple equation. So if you're unfamiliar, this is a formula that's sine x squared plus cos x squared equals 1, right? And so in this question, they've already given us the value of cos, which is -3/5. Sine x squared plus -3/5 squared equals 1. So you're basically subbing the value of cos into the formula. And so you get sine x squared plus 9/25 equals 1. Now, some people will ask you, they'll ask me, what happened to the negative sign, right? What happened to the -3? So when something is to the power, when a negative number is to the power of 2, it's always going to become a negative. So for example, if it was -4 to the power of 2, it'd become positive 16. That's a simple way to put it. And after you get that, you can do sine x squared. Whoops. The squared is on the outside. Equals 25/25 in order to match the denominator. You get that from the 1 to match the denominator, minus 9/25, since you've moved the 9/25 to the other side, and it becomes a minus. And after sine x squared equals 16, I believe, 16/25. And after you can square that, you can cancel the square on sine. So you get sine x by itself. And that goes to sine x equals, it's going to be root 16/25, which just equals 4/5. Now, don't forget the plus minus. There will be a plus minus, like when you cancel out a square, there's going to be a plus minus in front of the square rooted numbers. But if we look at the domain here, the domain is from 90 degrees all the way to 180 degrees, which is pi. And so sine is actually positive in the first quadrant, the second quadrant. And so our answer is going to be positive 4/5. I've just skipped a step. Now, tan x. We know tan x to be the result of sine x and cos x, or should I say theta, divided by. And so we know the value of sine x, which is -4/5. And we're already given the value of cos x, which is -3/5. And so we're going to divide that. Divide by -3/5. And a simple way to do this is just make it a times relation and flip the two numbers. -5/3. And so the 5's cancel out and the negatives also cancel out since there's 2. And that gives you the sum of 4/3. So tan x in this case equals 4/3. This question is asking you to find the amplitude, range, and equation of the graph below. So we can already tell that it's been translated. It's been translated by pi over 3. So we're going to start off. We already know the amplitude to be 4. The amplitude's going to be 4, since it starts at 1 and goes all the way down to 3. So the amplitude is 4. The range of this equation, we don't know that yet. The period is going to be pi over 3 plus pi over 3. And that gives us 2 pi over 3. Now we know the period, and so we're going to sub that into the equation of finding the period. Gives us 2 pi n over 3 equals 2 pi. And that gives us, you move that to the other side, 2 pi n. Oh no, you divide the 3, sorry, algebra problem. 2 pi n equals 3 times 2 pi, which is 6 pi. And then you basically have to rearrange n for itself. And so you get n is equal to 6 pi divided by 2 pi. So n equals 3, which is the coefficient of x. Now, what type of graph, how do we tell what type of graph this is? So this is obviously a sine graph that's been translated left by pi over 3, and it's also been translated upwards by 1. And it's also been reflected. And so the equation that we're going to get with this one is, let me just write that out. We're going to slowly fill in the information that we currently have. And so the period is, okay. All right, so 4 sine 3x plus pi over 3 plus 1. So this right here is going to be our equation, right? This right here is going to be our equation. And in order to find the range, you have to do what we did earlier, which is this number here, 1, plus and minus the 4 in front of sine. So we're going to do that. 1 minus 4 equals negative 3. 1 plus 4 equals 5. And so our range is going to be negative 3 to 5, included brackets. So 2 pi over 3 is going to be your period, amplitude of 4. This is your range right here, and this is going to be your equation. Okay, solve each of the equations for x given this domain right here. So we're going to solve for x on the unit circle as we did before. So root 2 cos 2x plus 1 equals 0. Move 1 to the other side and makes it negative 1. And as I said before, because root 2 is in a times relation to cos, you get rid of it, move it to the other side by dividing it. So you get cos 2x equals negative 1 over root 2. And we all know that is just this before rationalizing and this is negative 45 degrees. So if we draw that on a circle, where on the unit circle, which quadrant is cos negative in? It's obviously the first one, no, the second one and the third one. And so you're going to input that. So it's going to be pi over 4. Pi over 4. So you start from 0 and you go all the way to pi. And this is when you get your first two answers. So also, I should note that the domain, it changes because of the coefficient of x. So the new domain for this equation would actually be 0 all the way to 4. So we get 4 answers in this equation. So we get 2x equals pi minus pi on 4 and pi plus pi on 4. And now you go all the way to 2 pi. But because there's nothing here, we're going to keep moving along. So eventually you get to 3 pi, and that's when you get your last set of answers, which is 3 pi minus pi on 4 and 3 pi plus pi on 4. Now you're going to simplify all these answers. You're going to simplify these. You're going to work out what pi minus pi on 4 is, and basically get what these are, and you're gonna still have a 2x in front of it. And in order to get rid of this 2 in front of the x, to get x by itself, you're gonna need to divide 2 by every single one of these answers that you get, right? So for example, if you were to divide 2 by pi on 4, it would just become pi on 8. So the final answers you get for x equals 3 pi over 8. I'm skipping a step. 5 pi over 8. 11 pi over 8. And 13 pi over 8. Remember, we're not going over the domain still. We haven't gone over the domain. Now for this equation, it looks a little bit harder. So for the same, we're going to change the size here for cos 2x plus pi on 3 equals 4. And we're going to 4 divided by 4 just equals 1. And now we've got cos. We've got cos and what's inside the brackets by itself. And there's no need to do more. So cos 2x plus pi on 3 equals 1. Now, on the unit circle, where is cos, right? Like, if we're talking about what cos is essentially the measurement of the x-axis. So when it is the x-axis 1, it's going to be 0, right? It could be 0 and pi, it could be both. So x equals 1 here. And so we do our answers of 2x plus pi on 3 equals, hold on, let me just separate this page. Our answers of 2x plus pi on 3 go from 1, and it goes from 2. So 0, right? It goes from 0. It goes from 2 pi. Because the coefficient of x, we get 4 answers. Coefficient of x is 2. And so that changes us to the same domain as this one. So we get 4 equations, essentially. And so we get another set of, what's it called? Of answers when we reach 4 pi. And now we've got essentially just our two answers, because, right, this one doesn't count, right? We can start moving everything from this side to the other side. And so that's what we're going to do. First, we're going to move the pi. So 2x equals 2 pi minus pi on 3. And 4 pi minus pi on 3. And then after you get that, you're basically just going to divide everything by 2 to get x by itself. And the answer that you're going to get is, well, two answers. X equals 5 pi on 6 and 11 pi on 6. This equation looks hard, but it's actually very, very easy and very, very simple. And so is this one. Now, this question is telling you to use your calculator, which is fair. You'd have a very hard time. I think it's actually impossible to do this by hand. Use your calculator to sketch the following graph. No, it is possible to sketch the graph, but I was talking about a solve. Use your calculator to sketch the following graph in the given domain with exact values of intercepts and endpoints clearly marked. So if you use your calculator to sketch the graph, you can input a y value and x value in order to get a good view window of it. If you know how to do that, go ahead and do it. If you don't, I would suggest learning it. And so the graph obviously is an amplitude of 4. And so it's going to start at 4. It's going to go something like this. It's a little bit ugly, but that's fine. Just making sure I reach the amplitude here. Having a hard time sketch this graph. Boom. So it's going to look something a little bit like this. Yep. It's going to look a little bit like this. Close circles. Now we can tell that the graph has been translated left. And so you can basically use the equation here in order to find the intercepts by doing x equals 0 and y equals 0 and solving for x. And so the endpoint here is going to be pi over 2 root 2. This intercept, so there's going to be a couple of intercepts. So this is the endpoint right here. We have pi and 2 root 2, which is one of the endpoints. This intercept here is 11 pi over 12 and 0. This one over here is going to be 7 pi over 13. No, 12 equals 0. This intercept right here is going to be pi over 4. And this intercept here is going to be negative pi over 12. This one is going to be negative 5 pi over 12. And this one here is going to be negative 3 pi over 4. And if you're asking me, well, how do you find these intercepts? It's actually not as complicated as you think. Okay, in order to find the intercepts, you basically just have to grab this equation here and do what we did solving for x, basically solving for this. So you're going to have to draw the unit circle again. You're going to have to find out which angle it's positive or negative in. You have to go around and around and around and around. And then after, you get rid of the pi over 4 to the other side and you divide everything else by 3. And so that's how you get the intercepts. And the, yep, that's basically it. So this equation, it's asking you to find the values of A, B, and C. Okay, so A being the translation upwards, B being the amplitude, and C being the coefficient of x. So first, we're going to find the translation, which is A, and we can see that it has an amplitude of 30. Well, 40 all the way to 10. That's 30. Yeah, that's 30. Exactly right. And half of 30, which is going to be here, 15. See, it goes up by 15 and it goes down by 15, a total of 30. And so the amplitude B equals 15. And we can also see that it's been translated up by 25. You can see that it's been translated up from 0 all the way to 25. And this coordinate here, 25. And so A, our value A is going to be 25. And C, the coefficient of x, and to find the period. It's always, the period of a graph is always when it comes back to the starting point again, right? And so the way we're going to find the period is, we know the period is 12, and to find the coefficient of x, we're going to use that same thing that we did before. 12 equals 2 pi over n. You times the n to the other side, you get 12n equals 2 pi. Rearrange n by itself, you get 2 pi over 12. N equals pi over 6. So C equals pi over 6. The height of a bungee jumper. h meters above a pool of water at any time t seconds after jumping is described by the function. Oh, okay, so this is our function here. State the amplitude and the period of the function. So the amplitude and period, this is going to be an amplitude, and the period is just going to be 2 pi. We're going to use that formula. So the period, the amplitude equals 25. Period equals 2 pi divided by the coefficient of x. In this case is t. Doesn't matter, they're the same thing. 2 pi divided by pi over 3. 2 pi times, and you flip the symbols, you get 6 pi. 6 pi over pi. And so the pi's cancel out and it equals just 6. Period equals 6. What is the initial height of the bungee jumper? Okay, so this one, it's asking you to find the range, and you find that by, as I said before, plus and minusing this number by the number in front of cos. So the number of translation by the amplitude. So you get 20 minus 25 equals -5, and you get 20 plus 25 equals 45. But you don't need to worry about this part. It's only asking you the initial, which is the lowest point, the lowest value, which is -5. It's asking you to sketch the graph of the function given the domain. Clearly show the shape, the coordinates, and maximum and minimum heights of the intercepts and endpoints. Okay. We know that the maximum is 45. And we know the period to be 6. Now this is a cos graph. And so it's going to start like this. It's going to come down, and it's going to go like that. So that's going to be our graph. And over here is obviously going to be 3. Here and here's going to be just 4.5 and 1.5. So to find the intercept, obviously you do the same thing as we did before. Solve for t here. Solve for t, and you will eventually find the intercept. Yep. But in this case, you can just use a calculator, and you can just basically just do okay. You can basically just do y equals 0, and you will get the intercepts. You basically just input that into a calculator, solve for x, which is t in this case, and you will get the x-intercepts. Yep. And that's basically it. That's everything. After 4 seconds, is the bungee jumper on the way down or on the way up? So if you look at this, 4 seconds, it's going to be around here, right? And so it's going to be on the way up. We can tell from the graph. When does the bungee jumper initially hit the water? So this is the water, right? This is the water. And it hits it at, so you basically just want to input height as 0, and you want to solve that on your calculator for t. And if you do that, you will get t equals 2.386, which is the exact value when x equals 0, aka the bungee jumper hitting the water. For how long is he in the water? So you're going to sub in this value, this intercept right here. You're going to sub in this value for h, and you're going to solve that. And then you're going to also sub in this value for h and solve that. And so you're going to get these two answers. Right. Also basically just inputting the intercepts. The first intercepts and the second intercepts. Basically how long he was underwater for. And you're going to minus those two in order to get the time, which equals 1.229 seconds. At what time is the bungee jumper 10 meters above the water? I'm going to correct this to 3 decimal places. 10 meters above the water. So you're going to sub in 10 for height, and you're going to solve for t. And you're going to get two answers, which is t equals 1.893 and t equals 4.107. And that's basically it.